Hello friends, now we are starting new chapter, that is gear measurement. Before starting, let's understand what is gear. A gear is a toothed wheel which meshes with another toothed wheel to transmit power or motion from one shaft to another, as shown in figure here. They have advantage over friction and belt drive in that they are positive in action, a features which most machineries required. In order to have perfectly uniform relative motion between driving and driven shaft, it is essential that both gears be of perfect geometric form. Hence, during manufacturing, the inspection process is included to ensure high degree of accuracy of gears. As shown in figure, here the variation of speed can be done with the help of these gears. As shown in figure, if the small gear is connected with the machines, the speed of follower can be increased. Similar, if you want to decrease the speeds, the engine shaft will be connected to big gear and small gear. The so according to the speed requirements, we can change the gears and we can change the speeds as per requirements. Now, what are the functions of gears? The first function is for power transmissions. Next function is change rotational speed or torque and maintain constant speed ratio. Let's move to the next slide, that is gear terminology. We need to understand details about the gears. So first point is pitch circle. It is an imaginary circle which by pure rolling action would give the same motion as the actual gear. As shown in figure, pitch circle. Here this is the driven shaft which is connected with the engine shaft and which is rotating the follower. The pitch circle here is the indication, here it will touch. Then next is pitch circle diameter or pitch diameter. It is the diameter of pitch circle. The size of the gear is specified by the pitch circle diameter. Here we have to remember this point. The size of the gear is specified by the pitch circle diameter. Next is pitch point. It is the common point of contact between two pitch circles as shown in figure. Next is pressure angle or angle of obliques. It is the angle between the common normal two teeth at the point of contact and the common tangent at the pitch point as shown in figure. Here it is the pitch angle. It is usually denoted by phi. The standard pressure angles are 14.5 degree and 20 degree. Next is addendum. It is the radial distance of a tooth from the pitch circle to the top of the tooth. Here it is shown addendum. Addendum, it is the radial distance of a tooth from the pitch circle to the bottom of the tooth. Here it is shown in diagram. Next is addendum circle. It is the circle drawn through the top of the teeth and is concentric with the pitch circle. Here it is shown in diagram. Then dedendum circle or root circle. It is the circle drawn through the bottom of the teeth. Here it is shown. Next is circular pitch, which is denoted by PC. It is the distance measured by the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. PC is equal to pi dt, where d is the diameter of the pitch circle and t is the numbers of teeth on the wheel. Here it is shown in diagram where it is circular pitch. Two gears will mesh together correctly if the two wheels have the same circular pitch. Next is diametral pitch, which is denoted by PD. It is the ratio of number of teeth to the pitch circle diameter in millimeter. PD is equal to capital T by capital D, also equal to pi by PC, where it is the diameter of the pitch circle and T is the numbers of teeth on the wheel. Next is module. It is the ratio of the pitch circle diameter in millimeters to the numbers of teeth. This small m is equal to capital D by T. Next is clearance. It is the radial distance from the top of the tooth to the bottom of the tooth in a meshing gear. Here it is. A circle passing through the top of the meshing gear is known as clearance circle. Here clearance is required in gears to avoid friction and failure of the gear. That we should remember. Next is total depth. It is the radial distance between the addendum and the dedendum circle of the gear. Here it is indicated. Working depth. It is the radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. Here it is working depth shown in figure. Next is tooth thickness. It is the width of the tooth measured along the pitch circle. Here it is indicated on the diagram tooth thickness. Next is tooth space. It is the width of the space between the two adjacent teeth measured along the pitch. Here the indication is tooth pitch. Next is backlash. It is a difference between the tooth space and the tooth thickness as measured on the pitch circle. Next is face of the tooth. It is the surface of the tooth above the pitch surface. Next is top land. It is the surface of the top of the tooth as shown in figure. Next is flank of the tooth. It is the surface of the tooth below the pitch surface. Here it is shown flank of the tooth. Next is face width. It is the width of the gear tooth measured parallel to its axis as shown in figure. Next is path of contact. It is the path traced by the point of contact of the two teeth from the beginning to the end of the engagement. Here it is path of contact. Length of the path of contact. It is the length of the common normal cut off by the addendum of the wheel and point, which is denoted by P and Q. Next is arc of contact. It is the path traced by the point on which the pitch circle from the beginning to the end of engagement of a given pair of teeth. The arc of contact consists of two parts. Arc of approach, it is the portion of the path of contact from the beginning of the engagement to the pitch point. Arc of recess, it is the portion of the path of the contact from the pitch point to the end of the engagement of the pair of teeth. Here when the gear meshes, the contact is known as arc approach, and when it leaves the contact it is known as arc of recess, which is shown in figure here. Next is forms of teeth. There are mainly two types of profiles are used in manufacturing of gear teeth. They are involute profile and cycloidal profile. Involute profile. Involute is defined as the locus of a point on a straight line which rolls around a circle without slipping. So, it will be like this. In an involute gear, the profile of the teeth are involute of a circle. Next is lycoidal profile. It is the curve traced by a point on this circumference of the circle which rolls without slipping on a fixed straight line. It will be like here this. Cycloidal gear tooth profile is based on the epicycloid and hypocycloid curves, which are the curves generated by circle rolling around the outside and inside of another circle respectively.